Alright, so we got another SAT math practice, no calculator here. We got 8 questions. I'm just going to take it step by step, see what we can do. Feel free to pause the video, try it out yourself, see what you get, and then you compare your answer to mine. Maybe you did it faster, maybe you didn't. So let's see what we got here. Oh, that's my annotations. There we go. I'm going to go with a blue pen. Alright, let the function f be defined by f of x equals 5x minus 2a, where a is a constant. If f of 10 plus f of 5 equals 55, what is the value of a? Okay, so the first thing I'm going to do is I'm going to find f of 10 and f of 5. F of 10 is going to be 5 times x, which is 10, minus 2a. Or f of 10, I'm sorry, f of 5 is going to be 5 times x, which is 5, minus 2a. There we go. And we just need to add them together and make it equal 55. So 5 times 10 is 50, minus 2a. That is my f of 10, plus 25 minus 2a. 5 times 5 is 25. That's my f of 5. And we know that all equals 55. So let's combine some like terms. 75 minus 4a equals 55. Subtract my 75 over real quick. That's gone. Minus 75. So we have negative 4a equals negative 20. And a is going to be 5. Back to my answer choices. Letter C. All good. Next question. A number is called even-odd if it is halfway between an even integer and an odd integer. If x is an even-odd number, which of the following must be true? So if it's halfway between an even and an odd integer, we know it's going to be something like 1.5 maybe, or it could be 6.5. All we know is that it ends in a 0.5 because it's halfway between an even integer. And that value is x. So if 2 times x is an integer, well, if x ends in 0.5, multiply it by 2, we get 1. So the decimal is going to go away. So we know that any integer that ends in 0.5 times 2 is just going to be an integer. Or I'm sorry, any decimal that ends in 0.5 times 2 is going to be an integer. So that's true. So we can eliminate answer choice B. And we can eliminate answer choice D. 2x is an even odd. So even odd numbers, remember, are numbers that end in 0.5, like we defined over here. These are even odd numbers. Okay, so if we're multiplying one of these numbers by 2, like 6.5 or something, let's take 1.5. That would be 3. Or 6.5, that'd be 13. Well, those are just integers, not even odds. So 2 is not true. So I can eliminate C too. And I can actually eliminate E. But let's just double check with number 3. X is halfway between 2 even integers. Well, no. The definition just told us that, let me go with a different color here, that an even odd is between an even integer and an odd integer. So that's not true either. So only thing we're working with here is number 1. Put my blue back. Move on. Okay. If m is a positive integer, which of the following is not equal to 2 to 4 to the m? Well, rules of exponents tell us that if we have a number a to the b to the c, that's the same thing as a to the bc. We can multiply them together. And also another important rule I think we need to know here is a to the b times a to the c equals a to the b plus c. I think that's going to be important here too. But let's take a look at it. A. Well, that's just that rule we defined right there. So that makes sense. We're all good there. So A is not, A is equal, my pen, A is equal, so it's not A. So we're looking at what's not equal. 4 to the 2m. Well, 2 to the 4 equals 16, and 4 to the 2 equals 16. So that's going to be equal. That's the same thing. Eliminate answer choice B. Number C. Well, we're going to use that rule right there for C. I'm going to do it right here in this box. Divide these up in little boxes like this. I'll do it up here. This is B. Let's do C. Well, 2 to the m times 2 to the 3m, outlined by that rule I just defined there, is going to be 2 to the m plus 3m, and m plus 3m is 2 to the 4m, which we know is the same as 2 to the 4 to the m. So C is good. We can get rid of that guy there. 4 to the m to the 2m. Well, we can rewrite 4 to the m as 2 to the 2 to the m, which is 2 to the 2m. Then we have 2 to the 2m times 2 to the m. That's going to equal 2 to the 2m plus m, 2 to the 3m, which is not equal. So I'm not liking that one. Let me just double check with letter E here. 16 to the m. Well, 16 can be rewritten as 2 to the 4 to the m, which is 2 to the 4m. So that one is equal. That one's gone too. We're just left with answer choice D here. It's the only one not equal. Cool. Next question. According to the graph above, in which year was the ratio of the number of students enrolled at school B to the number of students enrolled at school A the greatest? Okay, in which year was the ratio of the number of students enrolled in school B to the number of students enrolled at school A the greatest? Okay, so we just need the dark color from school B be bigger, the most bigger proportionally to the lighter color. And just by looking at my graph here, I know it's not going to be 93 because that one's not great at all. And then we also need dark color bigger than the lighter color, so I know it's not going to be 91. And I can see by 90 and 94 that, well, the difference between the dark and the light is greater in 94 than 90, excuse me. So I can eliminate 90 right off the start. And if we look at these, we see that the difference between them is about the same, actually. It's about two gaps over here, it looks like that. But remember, we're talking about a ratio. So here, in 94, the dark is double the light. While in 92, if we double the white, it's going to be bigger than the dark. Here we can double the white, and it's the same size. So the actual ratio is going to be the biggest on 94. So I'm going to go with answer choice E there. Oops, wrong way. And the figure above which of the following must be equal to 180. Okay, we know these two lines are parallel, L and M. Okay. Well, one thing I know about the inside of a triangle is that some of its angles are 180. So I know that K plus P plus N equals 180. Now if I can just, let me make sure that's not an answer choice. Nope, I don't see it anywhere. But if I can just sub out K, P, or N, N, for another variable that would make one of these answer choices, then I know I'm all good. So let's look at the first one, K plus N plus R. K, N, and R. Well, I know P and R are definitely not going to be equal. I can't prove that P equals R anywhere, so I'm going to eliminate answer choice A. K plus P plus S. So we're saying N equals S. And if I redrop my picture down here, really just looking at this, looking at this angle and this angle. And I know from my geometry skills that if these two lines are parallel, that those I just marked right there, then those angles are going to be equal. And that's S, and that's N. So I know I can rewrite this statement as K plus P plus S equals 180, which is exactly what we're looking for. So I'm going to go with answer choice B. We just gotta, the key thing here is to remember those rules from geometry, I believe it is, where you have your angle, your parallel lines. Maybe you should know that these two angles are equal, vertical angles like that, and then these two angles would be equal too. Those are all important for the SAT, for sure, especially the no calculator. Okay, how many different ordered pairs x, y are there such that x is an integer, or x is greater than or equal to 4 and less than or equal to 10, and y is an integer where 4 is less than y less than 10. Okay, pretty simple here. Let's see, so x can be, if I can find the amount of numbers that are going to be x and the numbers that can be y, then I can just multiply those two together, and that's the number of pairs I have. So x is an even integer between 4 and 10. So I have 4, 6, 8, and 10. Okay, now for y, we cannot be equal to 4 or 10. So we're going to have 5, 6, 7, 8, 9, but not equal to 10. Okay, so we have 4 numbers that can be x and 5 numbers that can be y. We can just multiply those together. 4 times 5. We have 20 different combinations. Going with the answer choice C. Oh, we're good. Okay. The function above can be used to model the population of a certain endangered species of animal. If NT gives T as the number of decades after the year 1900, which the following is true about the population species from 1900 to 1920. So we want to know what it is at 1900. We want to know what it is at 1920. And then what the difference is. Okay, so at 1900, we're going to be 0 decades after the year 1900. So it's just 500 times 0.81 to the 0. And any number to the 0 is just 1 equals 500. So, okay, working with 900 here. 1920, we're going to have 500 times 0.81 squared, because we're going to be 2 decades after. Okay, remember, we don't have a calculator here, so we're going to try and use our brain a little bit to eliminate some options first, I think. So I know that it's going to decrease because this number right here, my ratio is less than 1. So I'm going to eliminate answer choice A and answer choice B right at the start because I know it's going to decrease. Now, if we look over here, we can estimate the amount it's going to decrease by just by doing a little multiplication by hand. So I do 0.81 times 0.81 real quick. 1 times 1, 1 times 8 is 8. And we're going to move, put my 0 here. 8 times 1 is 8. 8 times 8 is 64. Add these two together. 1, 6, carry the 1, 5, 6. And then I know we're moving 2 decimal places for each of these. Add those together, so we're going to move in 4 in our final answer. I'm going to go over 4 decimal places. Oh, I hit the wrong button there. Okay, let me go back. Oh, wait, I'm good. Oh, I added subtitles somehow. Okay, well, we'll just keep subtitles here for now. Let's see what I can do. So we got point. Oh, there we go. I can turn them off. Okay, wait. We have 0.651. So now we're working with 500 times 0.6561. And looking at my answer choices here, 0.6561 is just a little bigger than half. So I can estimate that if it's either going to be 180, 320, or 1,000, 500, a little more than half of 500 is going to be most like 320. Remember, that's... So if we're looking at 320 here, well, that's the amount left in 1920. So 1920 of 320. But if we want to know how much we decrease by, well, that's going to be 500 minus 320. That's 180. So a little bit of a trick question here. You got to make sure you really read what they're asking for and don't just jump to conclusions when you see numbers. I almost did it there too. Okay, all good. Last question here. A sphere of radius r inside a cube touches each one of the 6 sides of the cube. What is the volume of the cube in terms of r? Okay, always, I'm bad at art, but you got to make sure you draw these pictures because these are going to make it way easier to understand. And in here, we got a sphere. Get a little shading maybe. Get some depth. We know that this value here is r. That's a bad r. Okay, so volume of the cube, we just need the side length s, power of r. Or it's cubed, I'm sorry, because we're going to have s times s times s. Well, if we look at the side length here, r is half of the side length, so the side length s is going to be 2r. Volume equals 2r cubed. And remember, we don't want to just, that does not equal 2r to the cube. Or that equals 2 cubed times r cubed, which is 8r cubed. So don't get thrown off by answer choice B there. You know it's going to be E, because we're going to do our exponent rules properly. All right. That's all I got for you today. Hopefully you enjoyed it. Math is fun. Get some SAT practice in. Remember, just practice. That's the best way to increase your math score on the SAT. And have a good day, guys.